Okay, welcome to week 7. Okay, we're in day 1 right now of week 7, and we are continuing our work with rational functions. Last week, during week 6, we learned how to simplify rational expressions, and this week we will be solving rational equations. And some of the methods you've seen already, some of them are going to be new. So the first thing to remember is that rational expressions are fractions, and fractions are going to be undefined when your denominator is 0. So in the case of this proportion that we've been given right here, this denominator is just an x. And so that means that x can't equal 0 because that would make that denominator 0. So we cannot have 0 for x in this example. This denominator right here, its denominator would be equal to 0 when x is equal to 2. So we can't allow x to be equal to 2 because 2 minus 2 would then give us 0 in that denominator. So 0 and 2 are what we refer to as the excluded values for this proportion. What happens is that we're going to solve this just like we would any other proportion, and then whatever solution we get from it, we simply need to make sure that our solutions are not 0 or 2 for this proportion. If either of those values shows up as a solution, we exclude it from our solution set just like it was an extraneous solution, which is a word hopefully that you remember from our previous units. So it does just get excluded. I can't spell today. That's a T. Okay. And so you simply need to keep that in mind. As you're solving, keep in mind that you need to check your answers to make sure they were not one of the numbers that would have been an excluded value making a denominator 0. If your equation is already a proportion, like that first example is, you're simply going to cross multiply to solve it. So the problems we're going to be working today will not start out already as proportions because we have already done that. We did that during week 5 when we first introduced rational functions. So you can go back and look at those notes if you need to, but we will be cross multiplying eventually. It's just that the equations we're going to be doing today won't start out already being proportions. What we're going to be dealing with is equations that are not proportions. So we have 2 options. Option 1, we can combine each side of our equation so that our equation can become a proportion, so 1 fraction on each side, or we can clear the denominator. Today what we're going to be doing is we're going to be taking our equations and turning them into proportions so that we can solve them as we did in week 5. So if I look at this first example that we're going to solve, if I want this to be a proportion, the right side is already a single fraction. The left side is 2 separate fractions, but the 2 denominators are very closely related to each other. So what I see is that if I multiplied this first fraction by 3 over 3, that these 2 fractions on the left side would have a common denominator. And so the first fraction would become 15 over 3x. The second fraction already had that denominator of 3x. And so what that means is I can now combine the 2 fractions on the left side of my equation. 15 minus 4 is just 11. So I now have 11 over 3x on the left side, and I have 7 over x minus 6 on the right side. Okay? As we work through solving this, you need to keep in mind that this equation has excluded values. We have 2 numbers that will not work in this equation if they happen to end up being a solution of this equation. These 2 denominators over here on the left-hand side, neither one of them will work if x is equal to 0, because both of those denominators would then be 0. This denominator will not work if x is 6, because 6 minus 6 would put a 0 in that denominator. So as we are solving this, keep in mind that we need to be looking out for these two potential answers so that we could throw them out if we generate them. Now that we have combined the two fractions on the left, we now have a proportion, just like we did back in week 5. So we can simply cross multiply. When we cross multiply, the 7 will multiply to the 3x, and the 11 will multiply to the x minus 6. And so we will have 21x on one side is equal to 11x minus 66 on the other side. And now we can move all of our variables to be together, our like terms, so we can subtract the 11x to move it to the left side. So we now have 10x is equal to negative 66. And then we can simply divide by 10. And we get x is negative 66 over 10, which you could reduce to negative 33 over 5. Or you could even write it as a nice exact decimal. It's negative 6.6. And that solution is not either one of these excluded values. We still typically always recommend that you check your answers, but you have not run into one of the numbers you know would not work. The other number, unless you made an arithmetic error, the other numbers you generate should work. Okay? So the second one, I have the same option that I did in the first one, but what you might notice that's slightly different in this equation is that even though there are two fractions on the left side that don't have a common denominator, there are two fractions in the equation that already have a common denominator, and nobody says that you can't move things from side to side. So instead of having to repeat what I just did on the first problem and give these two fractions a common denominator so that I can subtract them, what I can do instead is I can simply subtract the 3/4 to move it to the right side. And so on the left side, I will now have negative 3 over x plus 2. On the right side, 5/4 minus 3/4 is 2/4, which of course would reduce. So really what I have is negative 3 over x plus 2 is equal to 1/2. And so I didn't actually have to give common denominators to turn this equation into a proportion. So what I can do now is I can cross multiply. Now that it is a proportion, I cross multiply, and I get negative 6 on one side, and I get x plus 2 on the other side. So now all I have to do to solve it is subtract 2. And so I get x is negative 8. And I know that that's going to work. And once again, I can check it, but remember that in this original equation, there was only one denominator that even had a variable in it. It was this one right there. And the only excluded value would be when x is negative 2, because negative 2 plus 2 would make that denominator 0. So the solution that I came up with was not the excluded value for this equation. And so once again, when I check it, I know that it'll work. Once again, unless I made an arithmetic error. You always want to check it just in case. Okay? Now what this gives us the ability to do is to solve word problems and set up word problems. And so what we have is we have a word problem that will step-by-step create a rational expression, and then we're going to set it equal to something so that we can solve it, okay, as if it is a proportion. So what we have is we have a cable company, Time Warner. They charge a $65 installation fee and a monthly fee of $32 for phone service, okay? And X is the number of months that you have the phone service. So it says first thing we want to do is write an equation for the total cost. So you as the consumer would want to figure out, okay, how much total have I paid Time Warner? And that total would end up being the $65 one-time installation fee plus $32 times the number of months that you keep that phone service, because it's going to be $32 monthly. And so each month an additional $32 gets tacked on to your total cost that you have now paid Time Warner. Then we can use that to take the next step. And the next step says that we can calculate the average cost. So if you want to figure out what is the average that I am paying Time Warner each month, what you are doing is you are taking the total cost over X months, and you are dividing it by the number of months. And so what you are doing is taking the equation you just generated, your total cost was 65 plus 32x, and you are dividing it by X months. And that will tell you the average that you are paying Time Warner each month. And so now that we've got this rational expression set up, you can figure out how many months you would have to pay Time Warner until your average cost per month is $33.25. So what you are doing is, here's the equation for your average cost. And you want to know, when is it going to be equal to $33.25? Okay. So we've now got technically a proportion. And the reason that's kind of a technicality, as you guys saw in week 5, I've got a fraction on the left, but I have an integer on the right. And that integer can be turned into a fraction by simply putting it over 1. That's what I mean by technically a proportion. And what that means is that I can still use cross multiplication to solve. I can multiply the x up across. And of course, I'm multiplying this to 1. So what I end up with is 65 plus 32x is equal to 33.25x. And now I can solve for x. So I would subtract the 32x, leave the 65 on the left side. That will give me 1.25x on the right side. And then I can divide by 1.25. And what I have figured out is that it will take 52 months. Because every month you're adding an additional $32 of your total cost, but then what you're trying to do is take that $65 installation fee and divide it up over a long enough period. That's why people get stuck in contracts, kind of the real world interpretation. You know, you don't want to waste all the installation and setup costs for things, so you want to stick with it long enough to divide that cost up. Okay, so hopefully that all made sense. We're not going to do a ton of application problem solving here. Just wanted to give you a few practice problems like that. For today, the practice problems that you yourself are going to try, they're just going to be the fundamental solving process. So here are 3 practice problems for you to try, because you already have enough material to practice. You need to worry about the excluded values. You need to practice the actual solving process. On day 3, we will learn another solving process, and then we might have time to practice a few more word problems here and there. See you guys again in a couple of days. Let us know if you need anything.